You know, when we think about the fight against cancer, our minds usually go straight to the tumor. But for so many patients, one of the toughest, most devastating battles is with something else entirely. A profound wasting of the body itself. It's a condition that can be even more life-threatening than the cancer it comes with. Today, we're going to follow the scientific hunt that's finally starting to turn the tide against this hidden enemy.
So let's dive right in by getting a handle on the problem itself. It's a syndrome with a name that, well, it pretty bluntly tells you how bad it is. Cancer cachexia.
The term actually comes from ancient Greek, from the words kakos and hexis. Put them together and it literally means the bad condition. And believe me, it is. This isn't just simple weight loss. It's a deep metabolic disorder where the body is actively and involuntarily breaking itself down.
And get this is shockingly common. We're not talking about some rare side effect. It's a debilitating syndrome that can affect up to 80% of patients with advanced cancer. In fact, it's a direct cause in about a third of all cancer-related deaths.
Now, it's absolutely critical to understand this one point. Cachexia is not starvation. You can't just fix it by eating more food. It's a full-on metabolic mutiny. It's a complex disorder, driven by inflammation where the body's own systems are turned against it, just burning through muscle and fat no matter how many calories you take in.
So, what in the world is causing this metabolic chaos? For years, the trigger was a complete mystery. Scientists started this massive hunt for a signal, some kind of molecule that had to be orchestrating this whole internal demolition. And they found a prime suspect, a protein called growth differentiation factor 15, or GDF15 for short. This is what's known as a stress-responsive cytokine. Basically, you can think of it as a biological alarm bell that your body rings when it's under serious stress from things like injury, inflammation, and especially cancer. Now, in a healthy person, you can barely detect any GDF15. But look at this chart. In patients with cancer, the levels just skyrocket. I mean, they go through the roof. This incredibly strong link was the first huge clue that GDF15 was directly involved in these devastating effects. And the evidence just kept piling up. It was all there, clear as day. The higher the patient's GDF15 levels, the more severe their weight loss, the worse their muscle wasting, the less appetite they had. It even meant they couldn't tolerate their chemo as well, and ultimately had poor survival rates. The culprit was definitely in their sights.
But that raised a huge question. How could just one protein floating around in the blood cause such widespread devastation? The answer, as it turns out, wasn't in the muscles or the fat. It was hiding in a very specific and very ancient part of the brain.
So the key question for the researchers was this: how does this rogue signal get from the tumor to the rest of the body to issue these destructive commands? They had to trace its exact path if they were ever going to figure out how to stop it.
And this is where the science gets really cool. They uncovered this precise step-by-step mechanism. First, the tumor pumps out tons of GDF15. Then, this protein travels all the way to the hindbrain. That's the body's old-school control center for things like appetite and metabolism. There, it finds its one and only receptor, a protein called GFRAL. Think of it like a key that fits only one specific lock in the entire body. And when that key turns in the lock, it activates a partner molecule, RET, which kicks off a disastrous chain reaction.
And the consequences of this hijacked signal, they're absolutely catastrophic. The brain is tricked into shutting down appetite. The nervous system gets kicked into overdrive, pushing the body into a state where it's just breaking things down way too fast. And then, the body gets the final terrible command: start consuming yourself. Break down your own fat and muscle.
You know, the clarity of the scientific detective work is just remarkable. And hey, if you appreciate these kinds of clear, structured breakdowns, please do take a moment to like and subscribe. It really helps us bring you more content like this.
So, here's the beautiful part about this kind of science. Once you understand the signal, the pathway, and the receptor, you can actually start to design a way to block it. This amazing insight became the foundation for a whole new way to fight back. The strategy became crystal clear. They needed to create a signal jammer. They had to develop a molecule that could catch that GDF15 message in midair, intercepting it before it could ever reach that receptor in the brainstem.
And this idea led to the development of drugs like Ponsegromab. It's a humanized monoclonal antibody, which is really just a fancy way of saying it's a lab-made protein that's been engineered for one very specific purpose: to hunt down and neutralize GDF15.
And the way it works is just so elegant. The antibody circulates in the blood, acting like a tiny bodyguard. It finds the GDF15 protein and latches onto it so tightly that GDF15 is physically blocked from ever docking with its receptor in the brain. The harmful message is never delivered. The self-destruct sequence is stopped before it can even begin.
Okay, so that's a brilliant strategy in theory, but here's the real question. Does it actually work in people? Well, let's take a look at the data from a recent landmark clinical trial that put this whole idea to the test.
The results from this Phase 2 study, which were published in the New England Journal of Medicine, they were definitive and incredibly promising. Compared to patients who got a placebo, the ones treated with Ponsegromab showed a significant increase in their body weight, a significant improvement in their appetite, and they saw real increases in both their muscle mass and their overall ability to be physically active.
And here's where it gets even more interesting. The benefits might not stop with just reversing cachexia. Because GDF15 is such a central stress signal, blocking it could have all sorts of other positive effects for cancer patients.
It turns out GDF15 also seems to be involved in that awful nausea and vomiting that comes with chemotherapy. On top of that, it also looks like it suppresses the function of our T cells, the very immune cells we need to fight cancer. So by blocking GDF15, we might not only treat cachexia, but also help patients tolerate chemo better, and maybe even make powerful treatments like immunotherapy work more effectively.
So this entire scientific journey, from identifying an ancient bad condition to understanding its precise molecular mechanism and then designing such an elegant solution, this represents a monumental step forward. Just as the trial investigators concluded, these findings firmly established GDF15 as a primary cause of cachexia. And that completely changes the game. It redefines what was once seen as just an inevitable decline into a condition that we can finally, actively begin to manage.